It started life as a bespoke product with Florida Power and Light, as we called it, Startup Wizard, and we could see the potential for the product. It was a bit sophisticated in terms of it. It was lots of scripts internally. We had to maintain it just specifically for that client. We now have a tool that is available for everybody to use. And I think one of the things I like about it is because some of the bigger organizations have strong IT skills, perhaps strong scripting skills, but a lot of the other organizations perhaps aren't so hot on that side of things. And it includes, I think it's simple to use. So once people understand how it operates, then I think most engineers should be able to adapt and do their own analysis. So essentially we were successful. We have a client in Ireland, ESB Networks. They are a vertical utility, so they have divisions that look after generation. They have divisions that look after transmission, but this is with their distribution network team. So I'll talk about that as we go through. So the two parts of the presentation is, first I want to present the EA automation tool to you, and apologies if we're duplicating what you did yesterday. And then I want to talk a little bit about how we're using that tool to meet the requirements of the ESB networks in Ireland. And that's a picture of their area. You can see they've got, I think, about 20 operational areas. So the EA tool, as I mentioned, it was originally developed with FPL. And it was further developed and then integrated into Synergi version 5 in its initial form. I guess at that stage it was more of a placeholder, and it hadn't been used significantly. But I've had the benefit of being able to do quite a lot of work on a couple of projects using EA automation, and certainly I know that the development since the version 5 introduction has been quite phenomenal. For example, with the clients I was working with, they were running with their old format on about, I think, about 64 substations would be a typical network that they were running it on, and that was taking 3 hours 40 minutes to process. And I think one of our colleagues mentioned from Dominion in terms of using scripting, a lot of the time is taken up in loading the model and then sending the results back down to the database. The analysis times are just a small fraction of the total processing time. We managed to reduce that 3 hours 42 down to 41 minutes. And that was by taking out some of the checks and balances that are put in when you load a model. Synergi does a lot of checking the schema, the numbers within that. We've reduced that down to speed up the process, and it now, as I say, we've probably reduced the time by about a factor of 6. So it is developing. I'm sure that as people use it, they will come up with, hey, there's a particular field that's in the normal GUI report that I would like to see within there. I'm sure the product team will be, as always, keen to sharpen the tool and welcome ideas for further development. So if an analysis that you want to do on a bulk analysis isn't there, I guess tell us about it and we'll see how we can help you. And again, if there are bits of data that you want to see in a report, then let us know as well. So the process for EA automation, the first thing is to create the recipe or script, and a lot of that would have been done by people writing Python scripts, perhaps writing Visual Basic or any of the other languages that enable that. Then run the analysis, save the results to the database, and then data mine the results. One of the things I want to look at with the ESB is what you can be achieved by data mining the results. That's certainly one of the more powerful parts of the project for us. We're at the very early stages of trying to understand what we can do, but hopefully we'll have a look at that and give you some ideas for what you can do. So in terms of running a bulk analysis, there's two main stages. The first is setting it up, and EA Automation will use some of the settings that you have in your standard GUI or a settings file to be able to run the analysis. So you need to set up the model and analysis options, and in particular in that is the setting of the exception limits. So your loading exception, your voltage exception limits, and any imbalance exception limits tend to be used by a lot of the analysis within EA. So you have to set that up within the model analysis options editor at the beginning. We'll just have a look at that in the demonstration a bit later on. Also, we need, if we're working with timestamps and weather settings, we need to set those up, and also set the analysis settings. So, for example, the number of iterations, the bandwidth that you're looking for the accuracy, those settings will need to be set up so that the analysis runs okay. And also the analysis type settings. For example, if you're running contingency, is it a feeder out? Is it a substation out? You would need to set those up in the GUI. And what you can do is you can save separate settings files. So if, for example, you're running a load flow and you want one set of settings, or you're running a substation out and you want another set of settings, and perhaps a feeder out and you want another set of settings, you can save individual settings files, and you can either load those settings file prior to running your EA analysis run, or the other option is to build into your script the loading of the script, the settings prior to as part of the process for running the analysis. Now, once you've done that and you set the analysis going, the first stage is to load the warehouse and set up everything up. It will then load the first substation model. It will carry out all the analysis. So if you've asked it to carry out perhaps a model check, a check data or a topology check, then you want it to run a load flow, and perhaps then to go on to do a feeder out contingency analysis. You can do that all in one run, or what you can do is you can do that sequentially with different scripts. So you have the option. So it will carry out, once it's loaded the model, it will cycle through all the analysis types that you've asked it to do. And once it's completed that, and it's put all the results into a buffer file in the output folder, it will then load the next substation model and go through the same process and build up all the temporary database files or BRF files in the output folder ready for the data dump at the end of the process. And once it comes to the last substation in your script, it will then write all the results to the database. So what sort of analysis can we carry out using that? You can see quite here, it's quite a comprehensive list already. I suspect there's not many areas of Synergi that isn't touched by this list at the moment. So you can do your model preparation, including load allocation. You can do basic load flow and protection studies, contingency and switching, and then into other areas, DER, reliability, some of the system health and feeder analysis. So there's a wide range of studies. Now, clearly, I wouldn't expect anybody to want to do all of those in one analysis, but it allows you to tailor your set of studies to meet your study objectives. So a quick demonstration. So here we are. I'll do a quick demonstration on the sample model. The first thing we would need to do is set up the on model. These two tabs here tend to be the most critical. If you're carrying out a contingency analysis, because it uses the reserve amps for part of the calculation. You would need to make sure for contingency analysis that you have, I think it's just particularly the emergency, isn't it, Larry? Yeah, you need to have the emergency reserve amps. So Synergi will calculate that and use that for contingency. Similarly, you have the with load flows and contingency, tending to use this voltage exceptions section. So you can set your high and low voltage, and for contingency, your low voltage for contingency. So emergency low volts would be used for a load flow, and a lower value perhaps you might want to use for contingency. So you're happy for the voltage to be slightly lower in a contingency situation rather than your normal running arrangement. And also, if you're interested in imbalance, you can calculate. It will flag up any high levels of imbalance on voltage or current. The line imbalance. Some people are only interested in imbalance if it's a heavily loaded section. So you can set that to a threshold there, so that it will only look at imbalance on, in this case, lines that are over 50% loaded. So that's setting all of those up. Again, we talked about time and weather. So you would perhaps want to set up the time and weather settings. And then finally, particularly for things like contingency, you would want to set up any number of transfers, the number of good plans you're looking for, and those sort of things. And I say talk about contingency because that's the one I've been working on most, but it's the same for any other analysis that you would want. You don't need to worry about these settings on the left-hand side, because that will be sort of sorted out within the within the selection in EA analysis. So I'm now going to create a macro for running EA analysis. So in this case, I'm going to use the wizard, and that will open. Did you cover this yesterday, Larry? Yeah, okay, so I'll whiz through it then. So in this case, I'm going to run a load flow, and I'm going to run it for 5 years. And I'm going to save it to, if you have it, shall you save it to the training database? Yeah, okay. I'm not worried about looking at the data because I've got some screenshots that I can use for that. Yeah, so I just want to sort of show, and I might want to call it, give it each table will have a prefix so that you can easily recognize that within your results database. So we will call this perhaps run 1. And then next you can talk about where's your sample model? Is it down the bottom somewhere?
Not at the,
There.
is
Is that one?
Yep.
If you're doing contingency analysis, you can elect for the number of adjacent feeder layers that you want to include, and change the time of day settings as well. And also you can set your automatic switches, whether you want to include or exclude the automatic switches in a contingency analysis. It will ask for the warehouse that you want, and I assume that's here somewhere.
That's optional too, because it's going to keep whatever warehouse Synergi has to start up.
Yeah.
So you could, unless you want to change the warehouse, you really don't need to do that.
Is it this one here? Because I'm not sure it uses the.
You got to just uncheck it.
Uncheck it. Does it work though? Because
yeah, go back.
Okay.
Just uncheck that box.
Uncheck that box. Okay.
And that way, it's just going to use whatever warehouse is in memory.
I'm hoping that's going to work, because I had a bit of difficulty with that when I was doing that. But yeah, okay. So these gives you the option to save the model back if you want. Now at this stage, you have 2 options. One is if you just want to do one run and you're not going to reuse that run again, you can just run the analysis directly from Run Now. Or alternatively, you can give it a name and save that, and it will save that so you can rerun that or edit it before you do the run. And if I rather than run it now, I'm going to finish, and to run the analysis from here, you can use the run facility. But before we do, just have a look at the recipe that's been created. So as I mentioned earlier, you can add items to that. For example, load a particular settings file using one of the commands that's available, or you can ask it to do some other things prior to either in preparation or post the analysis. And then when you run it, if you watch the screen pop-up window, it will show you the progress on there. So the first thing, it's loading the sample networks, and each time it's running. In fact, I've done more substations than I planned to, but that's not a problem. And then once it's completed all the substations, it will crash. Sorry about that. Once it completes the substations, what you'll see is that window will change to creating tables, and you'll actually see the table name and the data bin. You can see the sort of data clocking over in terms of its writing to that. So it's a fairly straightforward process. You don't need heavy scripting skills to be able to run it, but I think it's a really powerful tool. You could probably, for example, if you were running load flow on 3,000 feeders, you could probably complete that in a day. For 5 or 10 years, you could probably complete that in a day. And probably before, I think it would have taken a week, probably. I think it's probably more like it. So a massive improvements in the processing time, but also the amount of control. One of the things that you will get as part of that, if I can just find Larry's output folder, it should still be there. The output folder. Yeah. Yeah, I think it'll be here, won't it, Larry?
No, don't go there. It's,
Oh, you've got it set somewhere else, have you? There you go. So these are all the temporary database files, all waiting. Had that process has been completed, it would have written these files, but it retained them in this output file while you still had Synergi open. The other thing that it produces is, if I can find it, here we are, this CSV file. And you can actually use this CSV file to track the progress of the analysis as well. So if you want to know what substations it's up to, you can just, what I tend to do is just take a copy of it out of the output file and put it into another separate folder. Then I can have a look at it and see how many substations has it done, what substations has it done, and what analysis has it done. So that will track through to the end. What it does record in there is the steps in the analysis process. It doesn't actually record the the sending of the data to the database. And I think that if I suggested it's something we could do, it would be nice to be able to add that as one of the log items that goes to this file. So if you find, you know, you set it going overnight, and then you came in the morning, and you hadn't got the table of results there, you can start to have a look at, well, how far did it get through the process before it failed, and then perhaps have a look at that individual substation as to why it failed. Slideshow. And viewing results. You can see on the left-hand side, that's the set of tables that will be created in the database. It works equally well. I've used it with Oracle Enterprise databases as well as with Access databases. So it works equally well. And what you have is it's not like the set of tables you have in the GUI. Some of those are presented more visually so that you can see it, but as far as mining data, it's not as easy. This, you tend to get a flat database that has individual records for everyone. It's amazingly well referenced, so you can do queries by substation, queries by feeder, queries by year, and also many other ways of looking at the database. Each analysis type has a suite of tables that it will produce. Load flow produces exceptions, feeders, a set of results on the lines and loads. So protective devices, so it lumps into the protective devices, circuit breakers, fuses, reclosers, and also switches and transformers. I have recommended that we ought to add generators onto there now, because clearly people will be wanting to know what DER is doing on the network as well. So onto the case study. ESB advertised a request for proposals. They're carrying out a significant set of policy reviews at the moment, but also they are currently in negotiation with their regulator for the next price review. And as part of that, they have prepared a submission on their future investment requirements. They did that on the basis of their knowledge and their traditional strategic planning processes. But what they wanted to do was to have a health check on their network, which would either reinforce or amend their regulatory submission for the next pricing control period. So they wanted a complete system analysis to support the investment plans, and the objectives were to carry out a load flow analysis to test the performance of the network in the current year, to carry out an outage analysis using the backup feeders to confirm that the network capacity is there to meet that, but also to test the network's resilience to load growth. So they didn't want to do a traditional multi-year analysis. What they wanted was a set of a growth scenario that we can apply to test how much load growth that the network can withstand. And with that in particular mind, they have a growing use of heat pumps in Ireland as a rural country, the increase of electric vehicles over years, and also they have some quite load intensive developments, like they have quite a lot of data centers being located in Ireland as well, and also plans for, particularly in the city centres, traction systems, metros or tram systems. So they wanted to see how resilient their networks are to that type of load growth. Just a bit about their network. They historically have built their network at 10 kV, the medium voltage network. As time has gone on, and for many years now, they have increased the capacity of that network by upgrading the existing lines to 20 kV. But there are still quite significant pockets of 10 kV network that are connected via a transformer, a step-down transformer. They have, as I mentioned earlier, 20 area network models. They build their models in Access. They don't currently use a corporate an enterprise system for managing the data. They have between 300 and 3,500 feeders and 500 to 600 substations. So the project plan was to get a sample pilot model. And what we did with that, we checked the model suitability, did some QA diagnostics on it to check topology, to check the data, and then to carry out an initial load flow and contingency analysis, and also apply. It's not the ultimate growth profile that we'll be using, but to apply a growth profile to then get some results. And then with those pilot model results, we have selected to create the pilot model results in Access again. And the basis behind that is because the team in ESB are used to working with Access. They don't tend to work in an enterprise database environment. So although we're pushing the limits of Access with it, we did want to give them something that they had the skill set to be able to work with going forward. And the report for this pilot model has enabled us to share with them some ideas for how they would want the results presented back to them. And we then agreed a template for the results for the bulk analysis following that result. And now we are just, it is work in progress. We have just received their full model. We're doing the QA on that model at the moment. And then over the next month or two, we'll be processing the bulk analysis on all 3,500 feeders for them. One of the things we had to be mindful of, if you work with Access, we have 20 area models, and each of those models is between 20 and 120 megabytes of data. So the total model memory required, if we were to combine all of those into one model, would be about 1.4 gigabytes, which is big for Access terms, but it's within the maximum size of a database for Access. I think the limit's 2 gigabytes. But the results, the model diagnostics and contingency analysis, Access will eat it quite easily because it's only 100 megabytes for each of those studies. But the analysis which generates the most results, particularly with the lines table, is load flow analysis. So we've estimated from the pilot study that we would need 15 gigabytes of capacity to be able to accommodate that within Access, and that is well beyond the maximum database size. So we know that we have to break down the results into sub databases to be able to present back the full set of results to them. Either that or what we can do is we can analyze it and then present it back, but we've chosen to give them the full data back. So we're working with how we can do that within Synergi, within Access. We did some research on that, and those of you who are more experienced with Access will know that you can link tables so that you can have a core data, a main database of 2 gigabytes, and then you can link that to several other databases, and SQL queries will look across the whole set of data's linked tables when you write a query. So you can almost treat it like an enterprise database, which is quite a useful thing to know. So the load flow analysis, what we're doing this is in two steps. The first step is to carry out run 1 on year 0, and that is really just giving us comfort that the model will run successfully without committing to a full bulk analysis and have to wait a significantly longer time to know that there are problems with the model. So we're doing the QA before, we're then running a year 0 load flow and processing the year 0 reports for review before we move on to run 2 and then carrying out the full bulk analysis on any of the area networks. Once we know that we have a robust model, we can then leap straight into the contingency analysis and run that. Now, what I've mentioned that we have 20 area network files. Each of those area networks will have orphaned connections to adjacent area networks for interconnection. So in particular for the contingency analysis, we need to have the ability to load adjacents from other area network models. And the solution to that, because we can combine all of those area networks into one Access database and still be within the data limits, we're going to create one combined model so that we can call in, I think looking at the contingency analysis, we need to call in 2 layers of adjacent feeders. So we can not only go to the adjacent feeder on the next area network, we can go beyond that to the network as well. So this is how we're presenting results. This is certainly from our point of view, and I'm sure some of you are more sophisticated in your reporting, where you've been using data mining on scripted solutions. We've developed a set of results, a results template. Now, I think this is got potential to develop. I think Carl showed you the use of Insight earlier. I think this sort of thing has a potential to develop into a much slicker tool, and we can use it for not only identifying, well, show me the high level view of the network performance, but once I've identified where the weak areas, can I now drill down into what that means, and to look at the granularity of the results. So this is the first one of the first graphs we presented, and this is a look at each individual feeder in an area network and the demand on that feeder. We've got some MVA and AMP values, and also the percentage loading on the feeder, and you can start to see quite quickly that those that have the highest level of load, that ESBR is quite a rural country, so the loading on their feeders is generally quite low compared to what you would experience in a highly populated area, a more densely populated area. But what they do have is some more issues with voltage, because they're taking, they're taking conductors a long distance with loads on the end of them, so they tend to have more voltage. And this was quite useful because already on the pilot study, they've identified that some of the voltage on their network in normal operating conditions is worse than they anticipated. So that's highlighted a need to consider. And one of the things that they will use this set of analysis for, in particular, is they're keen to find out where to prioritize the remainder of the upgrade from 10 kV to 20 kV. They want to identify where the high priority needs are for that. So this I think will inform that program going forward. The other thing we can do is rank them by the number of exceptions, and that quite clearly draws your eye to the feeders where there are most issues with. We also break down the exceptions by device type. So I think what I've heard this week in some conversations is similar to what their experience is. They're not entirely 100% sure of what fuse ratings they have out there, and that's mainly because the line crews, something blows, they might just put what's on the van, or they might say, oh, they might upgrade it because they think it may be due to load rather than fault. So that they wouldn't necessarily focus in on the fuse, but certainly if you're getting line overload exceptions or transformer exceptions, then they would want to look at those in more depth. And this is an overloaded conductors report. So what we're doing, we have identified sections that are operating at over 100% loading. We then are combining that data with the conductor length and conductor type from the model database, and that produces a report so that you know on a feeder what length of conductor is overloaded, and also what type of conductor is overloaded, and that will enable them to build investment plans if they're looking at uprating programs or replacement programs to increase the size of the conductor. And then also we list the sections that are affected by that, so that you can produce a table there. We have similar approaches for voltage and voltage imbalance and amp imbalance. They don't have much in the way of voltage imbalance. They do have quite significant amp imbalances because they have a lot of single phase laterals on their network. but that isn't something that concerns them because they tend to be quite low loaded laterals. The contingency plan, what we're doing in year naught, we're producing a table of the number of plans, so that you can then start to look at how many feeders do we have with no good plans, and that's with a 2-layer and I think up to 6 switching operations. So there are a number where they're already not able to meet their requirements. In terms of growth, what we wanted to do is to provide some good visual signals for when they need to start to think about problems. So this the sample growth profile we used was in 2% steps. So we had between 0 and 20% growth. So 20% growth on the right hand of this table, 0% on the left hand side, and we used. I was quite pleased. I haven't used the reports capability of Access. I've tended to export to Excel, but anything you can do with graphs and tables in Excel, you can do within Access. So that was quite helpful because it saved a lot of data transfer, and you can also contain it all within one environment. So what we wanted to do there was using conditional formatting, is to start to color when you started to come up against regions. So for example, the one on the right is when your voltage starts to dip below 95%, we want to go to show it in orange, and once it goes below 90%, which is significantly outside their design criteria, then we made it right. But we're currently in discussion with them as to where they want to set those transitions. But this was just an example of what can be achieved with it. And this one was what we've proposed for contingency. Obviously, what we wanted to demonstrate there is in year 0, the majority of their feeders have suitable switch plans that can be used. But as you increase the load on the system, those options start to reduce. Interestingly, we were a little bit confused because after year 4, we had some were going from 2 switch plans to 3 switch plans, or the percentage loading was going from 70% to 30%. But when we did a bit more investigation, that's because what's happening is the primary solution becomes redundant after 5 years, and then it needs to go from perhaps a one switch pair operation to a 2 switch pair operation. But that second switch pair operation provides a lot more relief in terms of capacity. So everything stacked up, and as you can see, we're using color coding again to start to identify when we're hitting loading limits and voltage limits, hopefully when we've completed the studies. So what's the future potential? Certainly this can be used in enterprise databases solutions. We have been using it in a test environment on Oracle for quite a large client of about 4,500 feeders. One of the things that you can do is easily lift the SQL queries from one database to another database. So you can have a standard set of queries that can apply across your whole network if you're working with individual access databases. I think this will lend itself to dashboard and web-based, so that not only could the engineer who's dealing with the strategic planning process view these, it's something that could be made more widely available through your organization, so that managers or colleagues in other departments can start to have a look at, how resilient is the network going forward, and when do I need to start to worry about how it affects my activity. I would like to see it develop. I think it's got potential to develop also into a diagnostic tool. So you have a high-level set of results which identify the weak areas on your network, and then you should be able to then drill down seamlessly to be able to carry out more detailed studies on those particular feeders. So that's something I don't know whether you would see that as something that would be useful in your work environment, so that you're not having to then you can almost sort of carry out those studies seamlessly rather than having to take a list of feeders you want to have a look at, load those individually and do that. You could develop some scripts to do that automatically for you. I think certainly, I mean, this has been probably about 8 or 10 years in the developing from the original concept. Larry, is that probably about right? Yeah, yeah, but now it's going to be more widely used. I think we would very much welcome ideas for further development. One of the things that's built into the ESB model is that we didn't want to. We have 2 options, and we gave them those 2 options. One was, you know, yeah, this is a one-off exercise, and if you want to do it again, we can always come back to us and we'll run it again. Or what we've agreed with them is that we are producing documentation, training, and also scripts for them to be able to go away and do this themselves in future years. So it's an opportunity to get them introduced to the product as well. And as I said there, I mean, we can also, if somebody, I mean, because we all have busy day jobs, if it's something that you wanted commission on a regular basis, perhaps once a year or every couple of years, then we can offer that as a managed service as well. So that's all I've got.